Okay, so to continue, interfacial defects can fall into the following categories. So you have the external surfaces, the grain boundaries, the twin boundaries. So twin boundaries is when you have identical crystals. Okay, in short, you have two different crystals who at the grain there, they'll have their border atoms aligned perfectly with the next atoms of the other crystal. Then you have the stacking faults and the phase boundaries. Let's come to, I hope we have a picture there of them. Oh yeah, there is going down. Okay, so what are external surfaces? These are surface atoms of a crystalline that are not bonded to the maximum number of nearest neighbors, are not satisfied and give rise to surface energy. So the surface energy that arises from these surface atoms, okay, what are known as external surfaces. So to reduce this energy, materials tend to minimize the total surface energy if possible. Okay, so we come to grain boundaries. What are grain boundaries? I think we'll be talking about this. Separating two small grains or crystals having different crystallographic orientations in polycrystalline materials. Various degrees of crystallographic misalignment between adjacent grains are possible. So I think we've looked at this enough. We looked at this even earlier today. So these are grain boundaries where the boundaries align. Okay, then twin boundaries, like I said, you see there's this grain here, okay, or crystal, and then there's this other crystal here or grain. Then where they are meeting at the boundary, what is happening? You find that the atoms are exactly aligning, exactly, almost as if it was just one crystal. So it's like a mirror image position. The boundary is located at mirror image positions of the atoms on the other side. So that's basically the types of locations, or the types of dislocations that we have, or imperfections in solids. This is where we end. Let's quickly move to our next one. Let me just quickly share with you. Okay, so we move on to now ferrous and non-ferrous metals. This one is much easier. I think this one, I'll just go through, but it's material that you can actually go through by yourselves. But we'll just quickly go through, and then I know you have an exam and whatnot, you have time to study. So metals are classified. Metals can be classified rather under ferrous and non-ferrous categories. So what do we mean by ferrous quickly? Does anyone understand the word ferrous? What does ferrous mean? Brian? What does ferrous mean? When you say ferrous metal, what do we mean? Any idea, Simon? Okay, so quickly, ferrous, when you say a ferrous metal, a non-ferrous metal, ferrous actually means containing iron. Okay, ferrous means containing iron. So metals can be classified under ferrous, meaning metals containing iron, okay, or alloys of iron, and non-ferrous. Non-ferrous means that these are metals or alloys that do not contain any iron, I-R-O-N, iron, as others say. They do not contain any iron metal or any iron atoms in them. Okay, so under ferrous, meaning containing iron, you have pure ferrous iron. So if a metal is pure ferrous, meaning it's pure iron. Okay, it's basically iron. That's why you have iron here. or it could be a ferrous alloy. So these are alloys that contain iron in them. So that steel is an example. What is this? Steel is an alloy of what and what? Those that. What is steel made up of? Kennedy, Sichivula.
Made up of iron and carbon.
Yes, exactly. I was going to be worried if no one knew what steel is made up of. Steel is made up of iron, basically iron and carbon. And also other additives can be added to it, such as vanadium and chromium, just to enhance certain properties or certain anti-rusting. Can we please mute our mic? Just to enhance certain anti-rusting properties, chromium is added to iron, for example. Chromium vanadium can be added to steel, sorry, just to ensure that it does not rust. And when chromium is added, for example, to steel, it forms what is known as stainless steel. Okay, what we call stainless steel. Stainless steel is stainless because it's under the assumption that it does not rust. But also that and not rusting is under certain conditions. Under certain other conditions, actually, stainless steel does rust. Okay, so you have steel here. There are different types of steel. There's high carbon steel, there's speed, and there's high speed steel, and there's also high carbon steel and whatnot. So there are different types. We'll look at those also. Non-ferrous, we have the pure non-ferrous metals. So meaning that pure metals that are aside from iron, in short, that's what it means. So pure non-ferrous metals, we mean copper, aluminum, zinc, tin, lead, silver, gold, mercury. And mercury is known as the only non-ferrous metal that is liquid at room temperature. So we know that mercury is liquid at room temperature. For a while, we used to use it in our thermometers before we realized that it was a hazard to the environment. Then you have non-ferrous alloys. Okay, so these are alloys that do not contain iron in them. Okay, so which alloys are these? There's brass. Brass is copper and zinc. Bronze is copper and tin. Solder is tin and lead. Please, you need to know these also. You need to know this structure very well. So under ferrous metals, so we say consists mostly of iron and small amounts of other metals. So of course we understand that impurities, you cannot run away from them, isn't it? There's no such thing as 100% iron, like we mentioned earlier on. So there will still be other smaller amounts, but basically 99% of that metal should be iron for it to be considered as a ferrous metal. But ferrous, these are ferrous alloys. So under the alloys, we have the mild steel, cast iron. Cast iron is just when you extract iron, that is the cast iron. There's high carbon steel, high speed steel, and stainless steel. So rusting and magnetic properties in ferrous metals are both down due to iron. So iron high it rusts, isn't it? The rate of rusting is quite high in iron. And hence, that's why usually you find that anything that has iron in it or any ferrous metal usually over time would tend to look like this when exposed to those conditions of what? Of humidity and oxygen. So typical ferrous metals include mild steel, cast iron, and steel. So magnetism, we know that ferrous metals are highly magnetic, isn't it? So they easily attracted to a magnet. Okay, so applications, this you also need to know. So you need to understand what they are, ferrous metals, and where they are used. So mild steel is used everywhere. Our country is basically a construction site because it's building happening anywhere and everywhere. And steel is that glorious alloy that came in and saved mankind. And it's considered as one of the greatest discoveries of our civilization. It's steel. And concrete, cement and steel are the two very important materials that we have discovered in our civilization. And we use them everywhere. We use them for bridges, we use them for skyscrapers, for gates, screws, motor vehicle bodies. A lot of ferrous metals are used. Okay, so what is mild steel? Let's talk about mild steel. It's ductile and it's malleable. It will rust quickly if it is in frequent contact with water. Where is it used? It's used as nuts, bolts, building girders, as car bodies, gates, etc. That is mild steel. So in case you didn't know what your gate is made out of, most likely it's made out of mild steel. Melting point is 1,600 degrees Celsius. Okay, coming to cast iron, very strong metal when it is in compression, but also very brittle. So you remember what I said about brittle materials. Materials that are brittle tend to be very strong in compression. Okay, but also very brittle. The fact that cast iron is very brittle, that's why it's not widely used. Okay, so what we do with this cast iron, so while this cast iron is in molten form, we do what? We add carbon to it, and that's what forms steel. So the carbon in cast iron will enhance its ductility properties. So it tends to be ductile. So it consists of 93% iron and 4% carbon plus other elements. It's used as car brake discs, car cylinders, metal devices, manhole covers, and whatnot. So you have all this whole wide range. Melting point is 1,200 degrees Celsius. So those manholes, if you dunk, they are made out of cast iron. These machine car parts, which part is this? And the gentleman will help us. Which part of the car is this? In this diagram.
The brakes, madam.
And
the disc.
The disc, and what is this?
That's the engine block.
Yes, the engine block. And this is the what? The manhole. And what is this? The pillar drill.
That's...
In short, those lathe machines in the workshop, the wood workshop, metal workshop, usually are made out of cast iron. Very strong in compression, 1,200 degrees melting point. Okay, so we continue. We come now to high carbon steel. So high carbon steel is very strong and very hard steel. It has a high resistance to abrasion. I hope we understand what abrasion is. I think. Properties are up to 1.5 degrees. 1.5% carbon content. So it's up to 1.5% carbon content, very tough. As you can see here. So where is it used? It's used for tools, isn't it? So if you need something to clean up somewhere, you do not need it to wear out, be forming those lines and wearing out so easily. Okay, so it's usually used for garden tools. It's also used for chisels, making screwdrivers, chisels, saws, spring, garden tools, like I mentioned earlier. There's even a picture here. So screws. So these tips of the screwdrivers, these are most likely high carbon steel. The hammerheads, these are also made out of high carbon steel. It has a melting point of 1,800 degrees Celsius. Continuation on this was high carbon steel. Now we come to high speed steel, HSS. It's a metal containing a high content of tungsten, chromium, and vanadium. However, it is very brittle and also very resistant to wear. It's quite brittle, so meaning it's best used in compression. So when you're drilling, what forces do you think are acting on the drill bit? Are they tensile or compression forces?
It's compression.
Imagine you're drilling in the wall.
It's compression, madam.
Compression forces, isn't it? So compression forces are acting on this drill bit, right? So meaning you need something that is what? What property are you looking for? Something that is very strong during compression, isn't it? But also quite hard, because you don't need your drill bit to easily break. It has to drill through very hard surfaces, isn't it? Very strong surfaces. So you need the hardness or the toughness to be high, the toughness and the hardness to be high. Okay, you're not looking for ductility. Do you need something to be ductile? No, I don't think so. It can be brittle. Usually the compromise with brittle and ductility comes in to do with the tray, it comes in with hardness. So if you want hardness, you have to forget about ductility usually. So if you want hardness, you forget about ductility. You have to be brittle. But brittle is still good because in compression, brittle is not a problem. In compression, actually, ductile materials are very poor in compression. But what is strong in compression is actually brittle materials. That's why even ceramics are strong in compression compared to tensile forces when they're applied on them. Metal uses used for drill bits and lathe cutting tools. It's used where high speeds and high temperatures are created. So high speed, just from the word high speed, isn't it? So that drill bit is being acted on. It's moving at a very high speed, isn't it? Rotating at that very high speed. So you need high speed steel for that. That's why it's called that anyway, because it's ideal for metals that are used at high speed and high temperatures. It will still withhold melt. Of course, not temperatures beyond 1,400, because after 1,400, it's molten state. So the melting point is 1,400 degrees Celsius. Okay, so coming to stainless steel. Stainless steel is the most common one, isn't it? We see it everywhere, just from these pictures. I think they're very familiar to us. Starting from the sink, provided it's an original sink. I've seen the sink that rusts easily before. But good quality sink should actually be shiny like that. Stainless steel is very resistant to wear and water corrosion and rust. So what is it? It's an alloy of iron with a typical 18% chromium, sometimes 13%, 13 to 18%. Anyway, even 13, 14% is acceptable. 8% nickel and 8% magnesium content. Okay, that's the content of steel, this stainless steel. So it's got what? Iron, typically, obviously, and chromium, nickel, magnesium. It's used for kitchen sinks, cutlery. Of course, carbon has to be there. Carbon was missed, sorry, there. So it's used for kitchen sinks, it's used for cutlery, it's used for teapots, it's used for cookware and surgical instruments. Imagine if we're using material, surgical instruments that actually rust. It'd be causing a lot of infections in people. That would actually be fatal. So it's very important for you to have surgical instruments that are actually made from stainless steel, and of course they have to be periodically sterilized. Coming to non-ferrous metals. Examples there, we know aluminum, we know copper, zinc, tin, lead, silver, gold, magnesium. We'll look at these. So this is how they look like typically. I think in color, be able to tell. So we know the color of copper. What's the color of copper? I think ladies do well with copper or with colors. What color of copper is this? Try this. What color is this?
I don't know if it's red, brown, madam. I don't know.
Okay. All right.
It's copper, man.
Yes, it's copper, but what's the color? Copper color?
Yes,
It's
madam,
copper
it's
color.
referred to as copper color.
No, it has a color, brownish something, isn't it? Or yellowish something. Those who are good with the lineups and weddings, you should tell us what color this is. Once I attended the meeting for people who were on a lineup and they were choosing colors, I was hearing sack brown, something mustard yellow and whatnot. Even cockroach brown apparently is a color. I was shocked. So
I think it's cockroach brown, madam. Cockroach brown.
Okay. All right. We'll find it. Don't, please don't write cockroach brown in the exam. It's not an answer. We'll find the answer as we go ahead. Then aluminium.
Yes,
What's the color
ma'am.
of aluminium? Grayish, some shiny gray, isn't it? Which is similar to lead. So lead looks like this. Aluminium looks something like this. So it will be hard to tell apart, except maybe lead is softer, though aluminium is also soft. Brass is an alloy, isn't it, of copper and something. So it will obviously carry some of those core components, same as bronze. So in bronze and in brasses, there's copper there already. So you know those medals, the bronze medal, the bronze medal looks like this. What else? Zinc is also a grayish color. Tin is also grayish. So tins, those fish tins, tinned beans and tinned what? Those are alloys of tin. That metal is actually an alloy of tin. It could be aluminium, but if it's aluminium, it will be too soft probably. But aluminium foil is actually aluminium. Okay, it's just actually a sheet of aluminium. Anyway, so let's look at them individually and try and see their properties and why they're alloyed. So coming to aluminium, aluminium is widely used. We know aluminium. It's widely used in the kitchen, especially. It's light in color. It can even be polished to a mirror-like appearance. It's very light in weight. So I don't even like aluminum pots. Those light types, usually they'll be too light and the food quickly burns. The starches, especially like rice and shima, will quickly burn in them. Then there's the foil here. You can even see this is also aluminium. Aluminium also is used for the parts of a vehicle. Okay, so before we learned how to use aluminium, and plastic, we used to use the heavier metals. And that's why the vintage cars are actually quite heavier. Even just on appearance, you can tell that these cars were quite heavy because the metals we're not using lightweight metals like aluminium and fibers and plastic. Okay, so used for saucepans, cooking foil, window frames, ladders, expensive bicycles are usually made out of aluminium. Melting point is 660 degrees Celsius. So even these frames, the window frames, we have these modern ones coming up. Actually they are called aluminium doors and frames, I think. So they are made out of aluminium. Coming to copper, the ductile and malleable metal. It can be changed, what, you know these. I think you should know these by now. I asked you to learn the definitions of ductility and malleability. So highly ductile and malleable. It's often red stroke brown in color. So red, brownish red, or red brownish. I think it's still the same. Brownish red in color. It is a very good conductor of heat and electricity. We know this. We cannot overemphasize this point. Where is it used? It's used in plumbing, electric components, cookware, and roof coverings. An exam question will come say, name the, I like, when I feel sorry for students, I bring out copper, I'll usually put this question to say maybe write down the uses of copper, industrial and commercial uses of copper. Because I know copper is very common in Zambia. We're a copper producing country. But the question could be on aluminium, it could be on anything else. We just need to know where these, or the uses of these metals, or where they apply, the application in the industry. That's the melting point, 1084 degrees Celsius. Zinc, very resistant to corrosion from moisture. However, zinc is a weak metal and is used mainly for coating steel. Oh, by the way, coming to copper, it actually has healing properties. Huh? That may not be mentioned here, but scientifically, actually, it's safe to actually include that. Zinc has some properties in it that, how can I explain this? It more or less works like a disinfectant, actually. In ancient times, they actually used to add some coins, some copper coins. Okay, they'll place them in their water jars. They'll actually place some copper at the bottom there. Okay, and that copper would kind of help in disinfecting the water that they were drinking. And you see some people wear those copper copper bracelets. So those also they actually have some healing properties. So the copper atoms actually are known to have those properties in them. But I know the disinfectant one, that's a scientific one. The other properties, some of them may be. So I don't know if they're scientifically proven yet. Metal uses used as a coating on screws, steel buckets, etc., and it's used to galvanize steel. Okay, so why do we galvanize? So it's used to galvanize steel because why are we galvanizing steel? We're trying to protect it from corrosion. That's why we galvanize steel, and we use zinc because it is very resistant to corrosion. So this is where it is used. The steel buckets, the screws, are what we use zinc for. However, it's a weak metal, okay, and mainly used for coating steel. So that's why it's usually used as an alloy, okay? So it comes in as an alloy when we're looking for those anti-corrosion properties that it has, or the corrosion resistant properties. So it will be mixed with other metals so that those metals have an enhanced anti-corrosion side of them. Coming to tin, obviously just from the word tin, you know where it's used. Those tin, those food tins, they're actually made out of tin. Very ductile and very malleable metal. It is resistant to corrosion from moisture. It has a bright silver color in appearance. And tin plate is steel with a tin coating. Okay, so it's not entirely tin, it's entirely, but it's coating, a steel that is coated with tin. This is what these tins are. They're not in its pure form, we don't really apply it, but it's used as a coating, even for whistles. These were common during the gassing era. So these ones are made out of a tin coating. So they're used on food cans, beer cans. Those that drink alcohol are very familiar with this type of metal. Used as whistles, tin foil, and soldering. Those that love baking, I think these have been on our market for quite some time now. I've seen them lately. So these are also made of tin, a tin coating, or a tin foil. Coming to lead, it's soft, malleable metal, counted as one of the heavy metals also. The dangerous metal, I would say carcinogenic. It's a carcinogenic carcinogenic metal, because it's one of those metals that are likely to cause cancer in humans. Okay, highly carcinogenic. So it's a dangerous metal, but we still use it. It has a bluish white color after being freshly cut, but after it tarnishes, it will tarnish to a dull grayish color when exposed to air. Used for roofing, for roof flashing, okay. Used for batteries, lead batteries, as we call them. It's used for X-ray protection, by the way. It's used for its weight in many ways. So even, what part is this? This is the part of a tire, isn't it? Made out of lead. Soft and malleable. And these are its uses. Of course, for our country, we cannot overemphasize the dangers that come with lead. We know about the lead poisoning issue in Kabwe, okay, where lead used to be mined, and we know the effects that it has that can be fatal on human beings, especially children, brain damage, and whatnot, cancers, brain cancers that can come up with, from it. So it has to be used very carefully. Coming to silver. Soft, white, lustrous transition metal. It has the highest electrical conductivity of any element, and the highest, so this is what we talked about on Monday. It has the highest electrical conductivity of any element, and the highest thermal conductivity of any metal. So it's able to transfer heat at very high rates. It has the highest actually rate. The metal occurs naturally in its pure free form. So those are the components that are made out of silver. It's used for jewelry, high quality cutlery, also used for currency coins. Though I don't think there's any country that still uses silver in its purest form as a currency coin. I doubt it. We have alloys now. And it's used for sports trophies when they won a silver what for a silver medal and whatnot. The silver trophies, those ones we use it for. They're usually made out of silver. It's used in mirrors as a reflective metal. Also, I'm not sure about mirrors today, but those are generally its uses. Gold. Dense, soft, shiny, malleable, ductile. It has a bright yellow color. Okay. And traditionally considered attractive, which it maintains its shininess, okay, without oxidizing in air or water. So in short, it's not affected by air or water. It does not corrode per se. So if you have something made out of gold and it reacts with water and air, just know it's not pure gold. Gold resists attack by individual acids. It won't tarnish, discolor, crumble, or be affected by most solvents. Okay, so that's the beauty of gold. It's used mainly for jewelry, also used in computers as a conductor. By the way, it's used in computers as a conductor also. So you find it on the motherboard. Those small tiny components are actually made out of pure gold. It's used for its reflective powers because gold also actually has electrical conductivity of gold is even higher than copper. So it's usually used, that's why it's used as a conductor in those in computers. It's also used for its reflective powers to protect satellites. So even satellites will be coated with gold, okay, to protect these satellites. So it's because of its high reflective powers. This laptop apparently should be coated with gold. I've never seen one before, but the assumption maybe could be that they exist. Magnesium is used, I think we use magnesium a lot. It's used in pyrotechnic, in the fireworks. We're approaching December when people will be playing with those fireworks. Those fireworks are mainly containing magnesium. It's highly explosive. Fairly strong, silvery white, lightweight metal. It slightly tarnishes when exposed to air. In powder, this metal heats and ignites when exposed to moisture and burns with a white flame. I remember grade 8, grade 9 in the lab, we used to play with magnesium a lot because of its explosiveness. So when you drop some powder on water, it would explode and whatnot. It's used, oh yeah, so I talked about the uses here. So mainly used in pyrotechnic works, alloyed with other metals to make them lighter. Remember, stainless steel contains some magnesium in it, and it's more easily welded. 648 degrees Celsius, so it has a fairly low melting point compared to the other metals we've been looking at. Brass, mixture of copper and zinc. Copper is the main component. The brass bands. So it's used in musical instruments. It's brass band because of the material with which their instruments are made out of. They're made out of brass. It's also used for what? Copper bullets. Huh? Copper bullets are actually brass. And then what else do we have? These fittings for plumbing and whatnot. Plumbing fittings are actually also made out of brass. We have the screws here that are made out of brass. So it has a wide range of applications. It's stronger and harder than copper. Okay, it's stronger and harder than copper. So brass, meaning we add zinc there to enhance these properties, to enhance strength and hardness. But it's still not as hard and as strong as steel. It's easy to form into various shapes, a good conductor of heat, and generally resistant to corrosion from salt water. Resistance to corrosion comes in because of zinc. Zinc is is a material that has a high resistance to corrosion. Melting point is 940. Okay, so bronze also it's used for these ship propellers, it's used for statues, for medals, an alloy of copper and tin, hard and brittle, and then it has a very high resistance to corrosion. Why? Because of tin. Tin has high resistance to corrosion. Solder, we know soldering. Soldering. This is common with where you take your phones for fixing, your computers for fixing. Usually you'll have to solder if it's a hardware problem. Solder is used for electronics, plumbing, jewelry making, repair processes where metal parts cannot effectively or safely be welded. So it's a fusible metal alloy used to join together metal workpieces. So you actually just infuse, you let some solder melt there. Okay, just so you can join these two components together. So it's an alloy of lead and tin. Melting point is, that's why it's easy to weld. It's 200 degrees Celsius, has a low melting point. Okay, so that's where we end with these ceramic materials. This is just, the notes are poorly done. Anyway, they just give you an intro, but maybe due to time, I think this intro is enough for you. It's enough for you, I think. Not well in depth with ceramic materials. So this is basically the structure, okay? So under ceramic materials, glasses. So you have glasses, ceramics. So you have glass ceramics and just simply glass, the clear glass. Clay products are also ceramic materials. You have the structural clay products and the whitewares. Whitewares are those plates where you eat from. Okay, that's white china, where you do your mug cups, your plates, your breakable plates where you eat from. Those are considered as whiteware. Then the refractories, these are those bricks. Usually those are the bricks that are used for the lining of ovens, for example, kilns in industries, ovens, kilns. We actually use, those bricks are known as refractory elements. So fire, clay, silica, basic, and special, these are falling under refractories. Abrasives, cement, and advanced ceramics. So cement also is a ceramic. Advanced ceramics, what are known as advanced ceramics, all fall under this body of ceramic materials. So it's just important for you to just know maybe the classifications here is enough. So what is a ceramic material? These are non-crystalline silicates containing other oxides which influence the properties. So it's ceramic is a material that contains a metal and a non-metal. It's a combination of a metal and a non-metal. Okay, metal and non-metal, metal and non-metal, metal, non-metal. That's what a ceramic material is. Okay. Two prime assets of these materials are their optical transparency for glass, isn't it? Those who are wearing reading glasses right now, that is ceramic. And their relative ease with which they are fabricated. So we have capillary glass there, as you are going to Lusaka, if you're leaving Kitwe or vice versa, there we have a whole factory there where we have our glasses made. I do not know how they're still in operation now. Okay, so this is another, so refractories are very important because these are used as furnace linings. Yeah, so for furnaces, ovens, kilns, if you have been to a cement industry, there, the kiln, inside the kiln there, you have small, small bricks lined around it. Those are actually made out of ceramics. Okay, so the silent feature for these materials includes withstanding high temperatures without melting or decomposing. Because when you look at, for example, the kiln in a cement industry, that kiln heats up to 1,480 degrees Celsius. So you need a material that's going to withstand those temperatures without breaking down or disintegrating. And the ceramics are the best, the refractory ceramics. Those small bricks that look like pan bricks are actually the best that are used in those areas because they withstand high temperatures without melting or decomposing. And they provide thermal insulation. They have a way in which they actually keep the whole that heat in them. So meaning they're able to keep the furnace as hot as possible without the furnace losing that heat to the surrounding.